Welcome to Unit 4, Day 7. As a class, we just talked a little bit about what makes things perfect squares and perfect cubes. In this video, I'll show you how to use that skill to factor polynomials. First, a couple of background definitions. First of all, we've seen this before, but you need to remember that factoring, or to factor the verb, means to rewrite something as a multiplication problem. And we saw this primarily when we were studying quadratic equations. And factoring looked like this. You might think of it as the opposite of FOIL. Sometimes we even used the snowflake method to help us out. But of course, the underlying skill is called factoring. We're going to do the same thing today with polynomials that have a higher degree. And we're actually going to do it following three specific patterns that are based on your ability to see perfect squares and perfect cubes. So remember that a perfect square, we talked about this above, is when you can rewrite a term, for example, 25x to the fourth, as another term times itself, or another term squared. If you can do that, if you can rewrite it that way, we call the first term a perfect square. Similarly, for a perfect cube, it means that you can rewrite the original term as something times itself 3 times. The three factoring patterns we're going to use today have names that you will need to remember for your pepper quiz on Friday, and they have formulas that go along with them. Here's the first one. It's called a difference of squares. It should be familiar from Algebra 1. The formula that you'll remember is a squared minus b squared equals a plus b in parentheses times a minus b in parentheses. Basically, this formula is telling you if you see a problem like this, and the instructions say to factor it, you can factor it by using this pattern. In order to use this pattern, what you need to recognize is that your original expression involves 2 terms, and both of those terms are perfect squares. For example, x squared minus 25. X squared and 25 are both perfect squares because this is x times x, and this is 5 times 5. Since that's a perfect square, I can factor this into 2 binomials, and the 2 binomials are x plus 5 and x minus 5. In fact, if you FOIL this all the way out, you'll see that you get this original expression back. Now, basically what I did was I identified a as the square root of the first term, in other words, that thing that can be multiplied times itself, and b as the square root of the second term. If we do this with more complicated expressions, it's useful, in fact, just to write out what is a and what is b. So remember, a is something that can be multiplied times itself to get x to the 10th. If I just jot this down for a minute, I'm thinking of something squared that equals x to the 10th. And if I look at it this way, I realize that, if I put x to the 5th in that blank, x to the 5th times itself will equal x to the 10th. So that's going to be my a value. For the second expression, 9y squared, I'm still looking for something times itself to equal that whole expression, and I realize that 3y will work for b. Now that I know what a and b are, to factor this expression, I just use this pattern and I plug in for a and for b. Here's what it looks like. Again, you could check this answer by FOILing this out. The next pattern will look similar to you at first, but it's actually very different. So we're going from a difference of squares to a difference of cubes. And in this pattern, you'll use this formula when you see that both terms that are being subtracted are perfect cubes, not perfect squares. This formula, although it's tempting to think we can just keep this pattern going and add a third term, not going to work. So this formula is a minus b as your first binomial, and then a trinomial, a squared plus ab plus b squared. The basic idea is the same. I'm going to try and figure out something times itself 3 times that equals the first term, and something that times itself 3 times will equal the second term. Let's look at an example. X cubed minus 8. The first thing I notice is that both x cubed and 8 are perfect cubes. The first term is x times x times x. the second term is 2 times 2 times 2. That means that A is x and 2 is b. So I plug x and 2 into this formula, and here's the factored form that I get. A squared means x squared. A times b means 2 times x. And b squared means 2 squared, which is 4. And this is where you might start to recognize the work from your homework assignment. Again, with a more complicated example, it's going to be really useful to write down what a and b are. A is going to be something times itself 3 times that equals 8x to the 6th. It turns out that if I multiply 2x squared times itself 3 times, I would get that first term. Similarly, for the second term, if I multiply 3y times itself 3 times, I would get 27y cubed. Now I can plug these in, and I'm going to be really careful when I square the terms or multiply them. So the first part is easy because it's 2x squared minus 3y, just using a and b, following this original formula. For the second trinomial, we're going to square a, which means not just squaring x squared, but it actually means multiplying 2x squared times itself, which is 4x to the 4th. And then we're going to add a times b, which is 6x squared y. And last but not least, we're going to square b, which means 3y times 3y, which is 9y squared. And that's your final factored form. The last formula that we'll learn for today is the sum of cubes. It's almost like a difference of cubes, except that it has a plus instead of a minus. And notice that the formula is almost the same, except that the subtraction symbol is in the beginning of the trinomial, not in the binomial. In each of these formulas, there is one subtraction symbol. The location of it changes. You'll need to find a way to remember that. The idea here is the same. I'm looking for something times itself 3 times to equal the front and the back, and then I'm going to plug those things into the formula. For the easy example, we've got x cubed, which means that a would just be x, because x times x times x is x cubed. And 1,000, which means b would be 10, because 10 times 10 times 10 equals 1,000. This right here, if you would just change that typo to a plus, we'll use the sum formula, and this is what it looks like. For the second example, a is something times itself 3 times that equals 64x to the 6th y cubed. Turns out that 4 times 4 times 4 is 64. X squared times x squared times x squared is x to the 6th. And y times y times y is y cubed. B is pretty simple, it's just a 2. And then we plug in really carefully. A plus b is 4x squared y plus 2. A squared, which is the front of the formula, is going to be 4 times 4, which is 16, x squared times x squared, which is x to the 4th, y times y, which is y squared, minus a times b, which is this times this, which is going to be 8x squared y, plus b squared would be plus 4. On the next page, you have 4 practice problems. Please pause the video here to work those out. When you're ready to see the answers, you should move on to the second video, which is labeled Day 7, Part 2, and I'll start that video by showing you the answers.